It's perhaps surprisingly how fast the open source community can catch up. Would you agree with that? Or?
I think so. And I mean, we haven't really, I think we've only seen the beginning of that. And I think it's extremely exciting. I think we used to think that the tech giants had both the technical mode and the data mode and the financial mode. So they had sort of three modes in sequence or in parallel. Yeah. Turns out all three might be non-existent because it's getting so much cheaper to train. Most of the data, or probably enough data, is generally available.
Yes.
And the technology is public.
But just to, I mean, I agree partly, but just to have a discussion here and me disagreeing a bit, it's one thing to just put down like proof of concept. You have a model that you trained on some part of the data, but to actually build a product on that actually do work. It's so much engineering work to do that. It's so much work in having the legal, team that can handle all the lawsuits that are going to happen. There is a lot of money involved in actually deploying that model, and just imagining. I think for ChatGPT, someone said like $700,000 per day or something, just in inference costs.
And I would say that those are the other things, as you said, all the things that are legal and so on. The operation cost is another aspect.
Yeah. So I think there is a big moat,
and there is, and we have a great Swedish example of that. We have the GPT-3 model, which is sort of after the US and Chinese model. I think one of the bigger models trained. Yeah. And it's great as a research project, but we still haven't figured out a way to actually make it available. Yeah. Both for legal and financial.
Is that a perfect example? I mean, it's such a different thing to build a prototype and actually have something that is in production, that is legal to use, that is economically feasible to use, and that is a completely different thing. And there I think the tech giants have an enormous lead, right?
They have many more lawyers, I agree on that.
But you can go deeper on this, because what is the moat really all about? Because it's about invention. If you use Schumpeter, like or what's Rogers, like innovation adoption cycle. So there's one thing to technically make the invention happen. There's a completely different story to make that commercially viable,
monetizing
it and like this. So I think there's a way to look at this, that there is no mode technically. There's invention-wise. I would argue there is what's the mode. Now, to flip it into something that becomes a commercially viable product that scales and crosses the chasm, potentially there is a race going on now, because when you have a couple of players that really figures that out, it's going to be hard to catch up. So that's another way of looking at the mode in relation to, I guess, invention versus innovation and diffusion.
And I guess you could say that Sam Altman's genius in this is lying with Microsoft and creating both a way of funding whole operation, but also having the market by having Microsoft adopt this in all their products and in Bing and so on.
This is the true genius, right? So if you use those old writers on innovation, ChatGPT is not an invention. There's no new technology. It's the way to make it available and make it diffusible.
I think we should quote, from Data Innovation Summit we had like 2 weeks ago, and Google were there. Cassie
Kosyrkov.
Yeah, she made an awesome description of why I think it was such a big popularity, if we call it that. I tried to find a positive word instead of hype. With
attention.
Yes, good. That's a good term. But
it's even more fun when you talk about language models.
Yeah, attention. I actually got that.
Very good.
I noticed that Anders didn't, so I had to point it out.
I got it.
I was a bit late.
But he's not from the West Coast, so you can't expect too much.
Yeah. Not going there. Anyway, I think she made a good point, saying research-wise, of course, ChatGPT was not a big thing, and what really made the big impact here was that it wasn't AI that empowered and improved an existing product. It didn't improve like Google Search or Google Photos or Gmail or something. This was actually something that created a completely new product with a new user experience, a new way of working with a product. And that was the big thing. And that potentially caused the big hype. Would you agree with that?
I think that's partly true. I mean, I think, and it's so annoying these days that people confuse GPT versus ChatGPT.
Yeah.
I think it's the biggest confusion. I have big problems internally at Recorded Future making people say the right thing.
Yes. But okay, good. Let's be. I don't understand what you said right now. What is the confusion?
So, GPT models themselves, they are transformers, so the only thing they can do in life is to, given a long sequence of text, they can add one more token at the end.
Yes.
That's exactly the only thing they do, and they can do that repetitively. But the whole thing of keeping a context, so having the conversation, is what the chat GPT part is about.
Yes.
So using GPT underlyingly, but actually keeping the context, doing alignment so that of multiple possible answers, you can actually pick the best one. And then the sort of ludicrous part of it, then also adding the moderation part to try to keep it away from teaching you how to do bad things, which has created a whole new sport in terms of fooling it or tricking it into doing these things.
Exactly, but it's very interesting then, because, and I think it aligns with Cassie quite well, because it's a little bit like we have the underlying invention, the technology, we have the transformer, but what really gets the attention of people is the UX. We are truly, it's the chat thing.
Yeah. No, because and very. This is very much because that's what makes it human, right?
Yes, and that's what. And I think if I'm trying to follow on what you said and try to internalize it, I understood what you said. It's a little bit like before we have had AIs hidden and we didn't know it was AI. It was simply a recommender system in Spotify, and we got the list. The normal human user didn't realize there was AI going on. And here's the first time we are interacting. We're having a dialogue with the AI, and that is mind-blowing for us.
Yeah, and I think it's interesting. So, what I'm starting to understand now is the power of this is really the fact that in traditional UIs, take Spotify as an example. As you said, these things are built in. There's a button you press, and that actually goes off, talks to an AI model, and returns a list back, which gets presented, and so on. So every kind of functionality you want to build using the AI also requires you to sit there and code a UI and design things and so on. Whereas when you just use language, you get so much power immediately. So you could imagine. Spotify could have done a text-based interface to their different recommender systems way back, where you would said, what should I listen to next, and it would have come back with a list and so on.
And now when we start merging this, it's mind blowing, of course. But back to the core question. Did we conclude, is there a moat or not?
Yeah, perhaps we should give the background story, because I think we spoke about that before they turned on the mics here. But you mentioned before, Staffan, about the internal memo. I think at Google. Some engineer at Google wrote.
The presumed memo from the presumed engineer.
Could be ChatGPT.
I hear that you come from a security background. You can never be sure about anything. But at some memos said that there is no moat, and open source potentially and other actors can quickly catch up with the latest products that Google and Microsoft are now creating. But so in general, do you agree with that? Do you think that memo was correct, that it isn't that big of a moat, or it isn't as hard for other actors to catch up?
To be more precise, I think he, whatever wrote it, was right in the sense that there is no technical moat.
Yes, I agree with this.
Then you can say that there's a marketing moat or a financial moat and possibly other moats, but the actual underlying technology and the data needed to train another model with similar capabilities, no, there is no moat.
No technical in that, but perhaps engineering. If you want to build a product around it, at least there is some, and you need some kind of competence and resources.
No, I think there's a competence moat in here. Mm-hmm. So if you are into the game for real, hardcore into the game, there's no moat. But the problem is how many truly fully understands and can do a deep neural network.
And actually, there's a great analogy. So we sometimes, as Recorded Future, when we go out and tell people that we're harvesting all of the internet and organizing it for analytics and so on, the standard question you get from an engineer on the other side of the table is, I could do that myself.
Yeah,
theoretically.
And then we say, no, you can't. And then we start telling them about, as you say, exactly the operational aspects. The fact that, you're going to run a system with 10,000 servers, you're going to have uptime 99.9%, all these practical hands-on
very hardcore industrialization. And go back to Data Innovation Summit again.
Need to be quick here.
No, but theoretically, there's no technical innovation problem. Yeah. But when you start looking at the macro perspective of transformation, you have there's a lot of adoption events, there are a lot of activities, there are a lot of things built, there are a lot of things done and experience gained over many years in order to industrialize something. This is the moat. This is the moat.
There are moats, but perhaps not the one that you think of, perhaps.
It's the industrialization
moat.
Yeah,
no, I think it's a good way of describing it.
Operationalization, yeah. Okay.
Anyway. Industrialization sounds more hardcore.
Okay, cool. Awesome. With that, we would love to welcome you here. Very happy to have you here, Staffan Truve.
Thank you.
We've known each other for some time, and I still have some fond memories of those times. But you are the CTO and co-founder of Recorded Future, right?
Yes.
I think you founded about 10 plus or dozen companies or something.
Or had my hands in it in some way or another.
Yeah. And I'm not going to list your whole CV here, but you have you have a very impressive background, and you are on a board of directors for a number of companies. I think Vinnova as well in some way, or yes. And you've been part of RISE and a chairman there, and you were the CEO of SIX before it was
right. I was actually CEO of both SIX and Interactive Institute, two of the things which got engulfed by RISE when the government decided to throw everything into one.
Were you at SIX when Lalle was there?
Absolutely.
And a couple of other guys.
Lalle actually then went on and worked for some time at Recorded Future.
Of course.
Oh,
it's a small world.
It's a small world.
And you were the chairman of AI Sweden when I was there as well, which I'm not sure if that was the first time we met, or did we meet at SIX?
I think we met at some others. Yeah. We've met at SIX, some SIX events before.
Yeah. And you have a PhD, of course, was it in computer science, or what was your PhD from?
Computer science, but actually with a focus on, you could say, computer vision and the borderland between vision and language.
All right.
So if I wanted to really hype that, I could say that I did multimodal things in the early 90s.
Okay. Now I'm going to test you. In 20 seconds, what was your title and what was your ID on your PhD? Can you remember it?
Damn, if I remember the title, but I can tell you the idea. The idea was to have a language-based description of objects, and then essentially to use that to parse images. So you could take the language-based description, very much, let's get very geeky, just you build a compiler with Yak and Lex and so on. You could essentially generate an image compiler, if you like, which could then take the components in an image and see the relationships between them, and then say that, okay, now I discovered this piece of bread with a piece of meat with a piece of bread, and those things with this relationship, turns out it's a hamburger object.
So that was before deep learning, I hear, right?
This was very much symbolic, good old-fashioned AI, symbolic computing, yeah.
How did you feel when deep learning just took over? I
have to emphasize, though, that I actually then used genetic algorithms to optimize the image interpretation, so, it wasn't all that old.
But did you feel, what was your initial feeling when deep learning took over from 2010 plus or 12 plus? Was it something about all the work I've spent is not as...
I didn't spend that much work, so it was okay for me. But I'm jokingly telling my linguist friends, all the years they spent and then they got replaced by an LLM. No, I think, and it's interesting, as you know, we started Recorded Future. We started thinking about it back in 2007. So it means our first generation natural language processing was very old school. So we did parse trees.
Because and then we had the techniques that we knew.
Exactly. And we, analyzed the parse trees to find who was doing what, where, to whom, and so on. And then gradually now, we're essentially at our third generation on the NLP side now, where we're actually using, not super large models, we're using Roberta as our core for doing event extraction in text, for example.
Roberta model from Facebook, right? Or Meta these days.
Yeah. There's a rabbit hole here. Put it on the list.
Okay.
Adaptability. We put down on the Data Innovation Summit 2 years ago that when the innovation pressure goes up at a certain point and the productivity frontier moves at a certain pace, innovation and adaptability to the new ways of doing things is the only way to build efficiency. So the old way of incrementally improving on the old way you did it is dead. And I think,
and I mean that isn't that just the classical innovator's dilemma?
This is the innovator's dilemma for sure. There's nothing else. But but people seem to not really get this. So this is why I want to put this topic that you used really nonchalantly sort of said, we changed the core fundamental technical model for how our product works. That's what you said right now, in my opinion, when you are fundamentally shifting underlying technology idea for how the product works. This is and in the data space, that's how it works. Let's go to automotive or somewhere else, and oh my God, they don't get it.
They have this physical world to deal with, which makes it harder. But still, no.
Cool. And we are actually forced on time because you have to move on to another meeting with some EU ministers or something unimportant, right?
Some meeting, at least.
Yes, at about an hour from now. So we have to be better at keeping the time.
I will try to keep us away from my rabbit holes. I will
try to do the same. But just very briefly, we gave a quick introduction, but if you were to introduce yourself, how would you describe Staffan Truve?
So probably my standard description is actually that, I have a background in doing research, or actually I have a background in not knowing what to do. So, studied naturvetenskap, natural science at gymnasium. Then I studied engineering physics at Chalmers because that's the best way to not decide what to do.
All options.
I actually did a master in economics as well because I didn't know what to do. And then I became a PhD student because I had no idea what I was going to do. And then I started a consulting company because then you don't need to know what to do. But I think core is that I love to take things and sort of turn them into a little bit more of reality. So that's why I've been sort of living in this borderland between research and startups for 30 plus years now. Essentially either my own ideas or preferably others' ideas and, helping getting things moved. So I had this company we started back in 93, 94, something like that, called CRNT, which was sort of consisted of a bunch of people with a PhD in computer science who also wanted to build real things. So we, before incubator was a word, we were sort of a research-oriented tech incubator, you could say.
Interesting.
And that's actually the reason I got involved in the research institute side, was because I felt that universities were not very good at getting stuff out.
That's another interesting topic. I would
from TRL 1 to 9.
Yeah, but let's not go with that rabbit hole right now.
I think
topic. For one, you're such a humble person, and you just demonstrated that right now, not knowing what to do. But obviously,
I'm easily distracted. I can say that instead.
Okay, but I think also you're a person that have awesome communication skills, which I've been impressed with over a long period of time, as far as I've known you. But also that you actually do have very deep technical skills, which I think is really rare. And I'm not sure when I first heard your definition of CTO, but you mentioned that you were not a chief technical officer, you were a chief talking officer.
And chief travel officer.
And chief travel officer for I guess especially the last year where you have traveled a lot.
Yep.
But I truly admire that, so it's a great honor to have you here. Perhaps we should move quickly to the first topic, a bit about the Recorded Future. And if you perhaps could just describe a bit about how did that get started? What was the initial stories and happenings?
We can actually go back further. So this actually, in a way, goes back to 91, if you want to have a long story.
No, let's do the storytelling that leads into this.
Yeah, so the storytelling is that that time I was still a PhD student at Chalmers, but I was also responsible for the AI course at Chalmers, way back. And that's when I met Christopher Ahlberg, a very ambitious young student. He's 5 years younger than me. And our paths crossed, and then it turned out that he wanted, when he was going to do his master thesis, he wanted to do that in visualization. The best place to do that at that time was University of Maryland with Ben Schneiderman, who's one of the gurus of InfoVis. And I actually did part of my PhD work at MIT, so I happened to be in the US, and then I agreed to be advisor for his thesis. So I also got sucked into this. And my story these days is, and I think it's true, is that, being frustrated in trying to do computer vision, it was sort of a relief to have the machines generate the images and the people interpret them.
Yeah.
So,
and Christopher, by the way, is the CEO now, right?
He's the CEO, yeah.
Yes.
So what happened was that we actually ended up doing a research project together which sort of became his PhD thesis. And then we actually started a company based on that called Spotfire.
Spotfire.
Easily confused with Spotify, unfortunately. So we did that, and actually that's the reason Recorded Future is organized as it is, because after a couple of years we decided to move the headquarters of Spotfire from Gothenburg to Boston, and Christopher moved there. And
so Christopher's in Boston, right?
He's in Boston, yeah. Well, long story short, so we built a pretty decent company, and the idea was to do very general visualization tools. You could throw any data set in and you'd automatically get a very nice interactive visualization environment.
Are we talking typical Spotfire?
Typical Spotfire, exactly.
Yeah. So could you elaborate a little bit, because Spotfire got bought up by TIBCO, and it is in some circumstances, like I've been in Vattenfall, and of course we had TIBCO Spotfire as one of our vendors.
Very nice to hear.
Back in the day.
Mm-hmm. And you can be very frustrated that Spotfire did not become Tableau or Click. That others, there's a story here that other people actually figured out how to make it easier to use. We can come back to that later, maybe, or maybe it's another rabbit hole.
There's a rabbit hole on usability.
Yeah. Anyways, as you said, TIBCO bought Spotfire in 2007. Yeah. And the last years there, I had not been operationally or in any real way engaged in that. I was busy running a few research institutes, etc.
But you're still owning parts of it. So
I owned a little bit of it, yeah. But then Christopher and I started talking about doing something new. And it's really a combination of a couple. Christopher has what he calls his treadmill bright idea. He was running on his treadmill in his basement, and he realized, damn, everyone is organizing the internet for search, but no one is organizing it for analytics.
It's based on the Google idea, but for analytics instead.
Exactly. And at the same time, as you said, I was director for SIX. At SIX, we did a lot of machine learning at that time, but that was sort of the classic predictive maintenance, this building models to decide when a train was going to break down. Mm. But if you combine the two ideas, harvest all of the internet, organize it for analytics, and then throw in some predictive stuff, then you get Recorded Future.
Yeah. We want to record the future.
Mm. Exactly.
I mean, that describes the name, I guess, as well. Or how did the name come up?
So the third co-founder, who was also a co-founder of Spotify, Erik Wistrand, he's the programming genius behind things. The guy you never hear talk about. He's the sort of comparable to Ludde at Spotify, I guess, in a way.
Or the other Erik at Ludde, or at Spotify.
Yeah, exactly. He came up with the name. We have a tradition. So when we started Spotify, we had a terrible name. It was called IVEE, Interactive Visualization and Exploration Environment, which was the name of the research project.
IVE.
Terrible. Actually, when we started Recorded Future, it was called ZAP.
ZAP.
As in WhatsApp.
What's up? What's up? I remember
it has to be some beers involved.
That's a WhatsApp commercial.
Fortunately, very quickly, actually, Erik came up and said, and he sort of, I had a dream or something, we should be Recorded Future. So we've been, the name has been there for a long time.
So he just said, I had an epiphany, let's go Recorded Future, and you used, yes.
Yes. It's definitely, when you hear the name, it's yes. Right?
Cool.
Anyway, so when we started, our idea was, as I said, organize the internet for analytics, and we had two applications in mind. So one was to do geopolitical threat analysis, which we still do. We've been very sort of stuck to that. The other one was, remember that this started in 2007, was to let's use this organized thing to do analytics so we can sell interesting data to people doing quant trading on Wall Street. Really? Of course, then 2008 and 2009 turned out not to be the best years in mankind's history to sell anything to
Global financial crisis came.
Exactly. So we took 3 years, I think, to realize that there was a global financial crisis and we should not spend our time trying to sell to them. But then fortunately, some of our geopolitical customers said, cyber threats are becoming interesting. We think you should focus more on that.
So they took you from the bigger picture into a rabbit hole, so to speak.
Yeah.
One of the
we never abandoned the geopolitical side. We always had a part of our users who were primarily focused on
But
cyber.
You went deeper into one niche.
Yeah, exactly.
Of this broader topic.
So partial pivot, you could say.
Partial pivot.
Yeah.
PP.
And of course, the interesting thing is that, fast forward to 2019, all of a sudden, everyone cares about geopolitics. So these days, all our cyber customers are coming back to us saying that, geopolitics seems interesting. We should probably work more on that.
Can you just describe a typical company or organization that's interested in geopolitics? What do they?
Everyone, I would say.
But what do they want? Can you give an example?
They want to understand, given COVID and the war and supply chain crisis, they want to understand how do geopolitical events, whether they are sort of political events or things like disease outbreaks, natural disasters, how will that affect my company? And people realize that with the long supply chains we built, the butterfly in China, sort of which coughs, results in the factory being shut down, which means that 2 or 3 months later, my container with important stuff, my products, doesn't arrive.
Yeah. So anyone with a decent manufacturing and supply chain that needs to understand geopolitical landscape to understand how and when and will my chain break and what will the impact be?
Yeah, and it's both my supply chain and it's also what's going to happen to my market because of this.
Of course.
And what is the main focus today? How would you describe the products of Recorded Future?
So today we are we actually measured this. We are the world's largest private intelligence agency, if you like.
Ooh, how do you measure that?
So we actually did a market estimate. So we looked at all the companies we think are in this space, threat intelligence. Market size is roughly $2.5 billion as far as we can estimate on the public side. Our turnover is around 250 million, a bit more now, or ARR is 250 million. So we have about 10% of the market, and
you're speaking about dollars as well, right?
Yes, and as best we can, since it's English, you have to speak in dollars. As best we can estimate, we're about twice the size of the second largest company, which we won't mention here.
And maybe we can go straight into a definition here, because it's easy to talk about cybersecurity, and we now define threat intelligence. What is threat intelligence, and can you sort of differentiate? Can you add what is the difference between threat intelligence and cybersecurity? Or
so for us, threat intelligence, it's a matter of sort of having an organized picture of both the targets and the attackers. First of all, so we map the targets, the companies and organizations. We've done sort of the external view mapping of the attack surface of about 1 million companies and organizations today. So what that means is that we know, what IPs and domains they own. We've pinged their web servers. We know which old unpatched versions of web server software they use. We know that they have bad certificates. We know that their mail server doesn't have DMARC set as it should, and so on. Tons of things on the target side.
On the target side, yeah.
And then on the attacker side, we've mapped out the organizations.
Identified attackers.
Yeah. So and those are the classical 3 categories people talk about. There are the nation state actors, the APTs, advanced persistent threats. So we have a few hundred state actors who are known attackers.
The state actors as known attackers.
Yeah. So there's a bunch of Chinese, Iranian, Chinese, and North Korean, the classic ones. But also, the Western world, there are some intelligence agencies in the Western world who are also attackers. If you
really look into it,
if you hack Angela Merkel's phone, I think you classify as an attacker as well.
Yes, even if you're doing it from another Western country.
Exactly. And then there are several hundred state actors which we track, and then there are thousands of criminal actors. Some of them are larger, but probably mostly loosely organized things like the ransomware gangs, for example.
And this is a rabbit hole. Keep going, but how do you find the attackers? That's so interesting. But let's keep.
But then there's also individuals. There are guys who sell stuff on certain dark web markets, for example.
Yeah.
So we try to organize everything around them. Who are they? What tools are they using? What malware families are they known to have been used in previous attacks? And of course, attribution is a huge problem here. But there's enough information, evidence out there around validated attacks that you can actually map out this pretty well as well. And then we also, so we like to think of the internet as red, blue, and gray. So the red infrastructure, the known bad guys. The blue are the companies and organizations, the targets. And the gray is sort of the rest, the in between, the rest of the internet. And when we say internet, by the way, we think of everything from sort of top level. You have content, text and images and videos, and then you have the code which makes it run, both the good and the bad code, the malware. And then we have the sort of core parts of the internet. So, the IPs, the domains, the DNS system, the certificates, and even the network traffic. So we actually have means of getting network traffic. We can actually find traffic between known malware command and control nodes and their victims. So it's a...
Let's get back to you said you had 3 type of attackers.
We only started out with rabbit holes.
Yeah, I know.
So state actors, and then you have the plain criminals, as I like to think about them, financially motivated criminals, ransomware.
You're just a plain criminal. You're nothing. Okay.
And the ransomware gangs are a great example, completely opportunistic. They go after the weakest antelopes on the savannah and hack them.
For money.
For money only. And then you have the hacktivists, the ideologically motivated guys,
That's
who,
the third one,
think that the company is doing bad things and need to be punished, for example. And then, of course, the world is not that simple. Russia is a great example. They have their own state actors, of course, but then on the physical side, they hire the Wagner Group to help them. On the cyber side, they work with the criminal gangs. On the influence side, they hire the professional troll factories and so on. So even if you can look at these different categories, it's a mix.
It's a mix, yeah.
And just to go into one perhaps rabbit hole still, but you mentioned it, so I have to continue. And I guess most people agree with you that that's the case, that Russia has a number of other
affiliates.
Affiliates, okay, yeah. But how sure can you be about an attribution? Let's say that there's been a number of attacks in Sweden, of course, if you take Coop or whatever. How secure can you be if you were to do some kind of attribution? Can you just elaborate a bit more? How well can you potentially attribute?
I mean, it's complicated. I mean, so there are a couple of ways of trying to do attribution. I mean, actually, one of the ways you can do attribution is that we actually are deep into the criminal forums and the dark websites where people both discuss attacks and sell things and recruit people and so on. So sometimes you have evidence of that kind. Then, of course, there's traffic evidence, if you can actually trace things. But, of course, the fact that most attacks actually, or many attacks at least, originate in the US because they have a good infrastructure. So if you want to rent something to attack from, let's do something that's well connected. But also looking at the tools, so the fact that if you look at the malware families, they have over time been tied to certain actors. Even if, of course, it's a market there as well, so you can go and hire or buy from someone else. But, it's a classic sort of forensic game, really, of trying to find the indicators which allow you to at least hypothesize who the actor is.
So it's a classic detective puzzle,
Yeah,
and understanding how the clues...
And it's a great example, I always love to talk about building threat analyst centaurs, so have the algorithms do some parts and have the human analyst collaborate. And it's clearly a case that to do these investigations, I mean, machines can do some things, but you need the sort of the skilled detective who comes in there and also works on it.
Awesome.
But can I ask one question? And how do you productize this? How do you take this capability that you have built up, and in what way? How do I buy? Oh, I love it! I want to buy Recorded Future tomorrow. Oh, yeah. What do I do? What do I actually buy?
So we have 2 kinds of users: humans and machines. Mm-hmm. So humans, very simple. You buy licenses to get access. We've organized our product in 9 different modules for different sort of work categories. If you're a threat analyst, you have one license. If you work in a SOC, Security Operations Center, you have another kind of license for doing that. If you're a geopolitical analyst, there's a version for that. If you're interested in everything, you can buy all 9 licenses.
You have licenses for user persona?
For humans, exactly. Mm-hmm. And then there's an API, of course, for integrating this. So you can buy the data stream so that you can get our current list of all active malware command and control IPs so that you can configure your firewalls and your alarm systems for that.
So there's the engineering side of this is like you can get into the API streams from your core data flow.
But the key thing here is that, what we call the intelligence graph, which is our aggregated holdings, we just have one instance of that. So everyone sees exactly the same data. Mm. I mean, that's what really makes the model scalable, is that we spend a lot of money building that graph, but we can actually sell the same graph to everyone.
And just to elaborate a bit more what you mean with that. So Google has their knowledge graph that they try to collect about the world in some way and the current state of the world. Is that the right way to view the intelligence graph?
I think the intelligence graph is another knowledge graph, but a threat-oriented one.
Right.
So it's a massive knowledge graph, like a hypergraph over threats.
Yeah. But more than threats, so it's actually broader than that. We collect other things.
But it's a massive knowledge. It's a hypergraph with
Yeah.
all these associations and meta relations.
Yeah. But you can go in things, since we capture mainstream use, you can use it if you want to track where Xi Jinping is traveling in the world. You can go in and look for person travel events involving Xi, and you can see when did he go where, what did he have, what meetings with whom, and so on.
And of course, as we have the CTO here, we need to go a little bit nerdy, and we without revealing your secrets, we love to understand the text. What is going on? What is going on here? What is it? Is it a knowledge graph? What is the core components?
It's let's say that it's a graph. I don't even know how to define a knowledge graph, but so it's knowledge graph consisting of nodes, which are the
a graph database.
Yeah, graph data. It's not implemented using a graph database because it's too big for that, at least as we see it today. So, but it's actually you can think of the nodes in the graph being the nouns in the world. So there are persons, organizations, places, malware, software products. What you have, nouns essentially.
Nouns, yes.
And then the relationships, and then you can actually think of another kind of nodes, which are events. So there is a
noun events, events.
Yeah. So when someone tweets Ulf Kristersson is traveling to London, that's going to sort of tag on to the Ulf Kristersson node and the London node, and then there will be a new time-stamped relationship of a person travel kind between these two.
And so in a way, there's a graph going on here, and then where are there any algorithms or any? So is it just relationships or hardcore?
There's another kind of. So we also have ontological relationships. So Ulf Kristersson will actually be tagged in the graph as being the current Prime Minister of Sweden.
So the ontology dimension is quite important.
Yeah, it is. So one of the magic things you can do is then you can do what we call ontology-based search in the graph. So what you can now say is you can go in and query, give me any prime minister or any world leader who's traveling to London next week. Or you can say, give me any malware network traffic where the command and control node is located in China. So this notion of abstracting away from, first of all, the events abstract away from the concrete language used to talk about an event. And the ontology allows you to search at a categorical level.
And if we go and to get usefulness or get to adoption, how have you envisioned the user interface or how to use it? Because you explained we have a couple of user persona licenses, I assume there's some sort of...
So if you look at it traditionally, and here comes our heritage to information visualization.
Yeah.
So traditionally you could say we have a bunch of ways of visualizing this data. Essentially what you do is you query the graph,
Yes.
So you go in and you query, there's some little query builder where you can say, let's continue with this because it's simple to talk about. No, actually, let's switch to a cyber example. Let's say you go in and query for cyberattacks last 3 months when the target is in the banking industry.
Okay.
In Europe.
Yep.
Okay, so that's going to extract, if you like, a subset of the whole graph.
Yep.
And then what you can do is you can take that, and as they are timestamped, you can do a layout, so you can get a timeline. So volume-based timeline over how many attacks are it. Then you can split that timeline up by attacker, if the attacker is known, or you can do it by target, and you can slice and dice it.
And in the end, you have a UX headache problem. How do I visualize this? How do I make this useful for these different user personas?
Yeah. So now this is, I would say that up till 6 months ago, we spent the bulk of our effort, we did a lot of UI work to make it easy to use, but the sort of AI part of it has primarily been taking all this unstructured data in, organizing it so we could throw it into the graph. So the big news for us then, now we come back to GPT.
I was going to go here, but please go here yourself.
So what we just released a couple of months ago now is that we now built a new front end to this. So at the moment, what you're doing is that instead of just getting these different references, as we call them, the text fragments about the events, we're actually sending that through GPT and ask it to do a summary.
Yeah,
and it actually produces a very nice little succinct summary of things.
So the bottom line now, and this was like You took my thunder, because like what happens when we have now a completely next level interface in how we interact with data and vast amounts of
and
data.
now we come back to this, exactly the fact that the language is such a powerful way of interacting and describing. You don't need to build new buttons for every use case you have. And I have to add, and you can do wonderful things with using GPT for what it's really good at, which is to analyze text.
And synthesize something.
You can synthesize, but at the moment I'm actually more excited by the analytics thing. I have two great examples. I have to share them with you.
Yeah, please.
So one thing you can do, let's say that you're interested in geopolitical things happening around Taiwan or military operations around Taiwan.
Yeah.
But now you can actually then use our query language. You can extract what's being said in Russian and in Chinese, and then you ask GPT to make a comparison of these two things. And it does a brilliant job of that.
Wow, this is hardcore, like typical intelligence in any country. Like
exactly, this is where a sophisticated
guys who interpreting this is CIA stuff. What they're really doing and trying to understand.
And my other favorite example as of the last couple of days actually is what you can do is you've all seen the recent attacks by anonymous Sudan on Swedish companies and agencies.
Yeah.
So one cute thing you can do now, you can extract all things published by anonymous Sudan, and you can send it to GPT and you can ask it, given this Arabic text, can you tell me and the dialect of Arabic, can you tell me where this guy comes from? And GPT answers, this person appears to be coming from Sudan, and here are the evidences, the names they use, the dialect, the special words which indicate that this is Sudanese Arabic.
So all of a sudden, you're not only getting something that becomes another UX, but you're actually getting another augmented brain into the core intelligence work.
Yeah, no. So this is, I think we just only started realizing how powerful this can be. The fact that you're actually having an analyst, which, I don't speak Arabic, I can do this analysis now.
Yeah, but what I think is super important now, so people don't misunderstand this. So doing this work with ChatGPT, we are not using ChatGPT at all to try to hallucinate on what is true or not true. So here we have real data in a graph, but we are using it for what is really useful for, which is linguistic proficiency.
Yeah, exactly. So
is that fair?
That's exactly fair. And so since we started with summarization, because when our experience now when we measured this is that when we ask GPT to summarize things, it doesn't need to hallucinate. It's really sort of doing its job in a proper way.
Yeah.
Same thing for these another analysis. It could be fooled, but again, it does probably at least as good as a job as an average human analyst would do. And the key, as you say, is really to have
use it for what's worth, what it's useful for.
Yeah. And I think the key thing is, you have the language model, and then you connect it to our intelligence graph, which is the world model. So the world model, the real-time world model, that's another aspect of it. Real-time world model and the language model together, it makes it really powerful.
So if we just try to compare, the potential impact that GPT in general can have on the good side, that means for your purposes, but perhaps also later to talk about, what could be from the attacker side and what the impact could be there. But if we take and start with your side, I guess one is, as you said, to just analyze and compare and be able to understand text in a sense that hasn't been possible before.
No, so I think, it boils down to two very simple things. It boils down to making the human analyst significantly more efficient.
Yeah.
And the other thing, which people might not think about immediately, it's also, and we actually just done some measurements on this, is the fact that you can now have a very junior analyst do things which used to require a very senior guy. And everyone knows the shortage of cybersecurity analysts. So if you can just sort of lower the required skill level you have to do some work, that's going to be significant.
We have a new product model because you can now, let's talk off the camera.
Okay, so it simply empowers humans to an extent that makes them able to do tasks that wasn't possible before, and they do that to a much higher degree of competence in some sense, right?
No, I think that's a fair way.
And you also produce normally a set of reports. Is that something you're thinking about, empowering your analysts to write the reports together with, like in co-creation mode?
So right now, what actually people do is, Because very typically what happens is that some manager guy comes in and asks the analyst, I just saw this thing on CNN here. How does that affect me? And now actually the summaries we produce are good enough quality that you can actually have that as either the skeleton or actually the report you send back. So we have people say that, now I can produce in literally less than a minute what could have taken me a whole day to sort of gather the information, organize it, and write the report.
Really? So, and that's with ChatGPT or similar tools? Or?
GPT, let's say.
GPT.
Okay, yes. Can we go? I have one. Okay.
Unless it's a different topic, then wait, please.
Yes.
I'd like to just go, we had it on the question of, the positive use cases, how it can defend and secure different companies. But then if we move to the other side and potentially see, can GPT be used to empower attackers? What's your thought about that?
Of course.
In what way?
Well, the obvious one people are talking about now is that you can go from doing either very simplistic, high-volume phishing attacks to spear phishing, which has been traditionally very expensive. Now you can clearly see how you can automate spear phishing.
Explain what you mean, the difference.
So typically, the classic phishing attack is you're very simplistic. You send it out to 10,000 people, and a few of them will click on the link there. Or you do your homework, you analyze this individual, you figure out what their kids' names are, and then you
soft spots.
And exactly, and then you write them an email saying, your daughter Emily is right now in a very bad situation. If you click here, you can help her. Now, combine this having all the access to the information plus having GPT to formulate this. But there's many more. There's, code analysis is another thing where GPT excels, where, you can use that to probably hunt for vulnerabilities in code, for example.
Yes. Find and perhaps also generate code. Do you think, if you want to create malware in some way?
People have talked about that. The thing is here, if you look at all these AI use cases for the bad side, researchers have been screaming about it for years. Yeah. So far, we have honestly not seen that much of it in production, so to speak. I think probably because
the bad. See it? Do you think?
I'm sure we're going to see it.
Would you, if it were happen or would have happened, would you have seen it? Can you really see the difference if it's like a collaboration?
No. It could. That could also be a thing that it's hard to identify. But I think honestly, the bad guys have done well enough with their simplistic tools. They haven't been forced to innovate. Really.
But just as you said, it empowers junior people to do more advanced analysis on your side. Don't you think, normally if you create a malware, it requires some kind of technical skills, unless you're a script kidded, using a tool set. Perhaps this can simply scale from...
No, I think it's going to be exactly as I said, I think there is really no difference in how the bad and the good guys are being empowered by this.
But that leads also down to a completely different rabbit holes. But let's park it on if we regulate the good guys. We all need to be on the same playing field here. Otherwise, this is going to be very unbalanced.
This is actually my favorite problem right now. The fact that all the talk about regulation or ethical AI. So the big problem. My pitch is the big problem with ethical AI is only the good guys care about it.
Exactly.
The bad guys, however we define the bad guys, they will not care at least. And now we get back to the moat thing. If there's no moat...
We are creating a moat for ourselves in the wrong way.
We're doing a regulatory moat to the advantage of the bad guys.
So I think that's a great quote. Sometimes we try to collect quotes to get print on T-shirts, and I think the problem with regulation is that only the good guys care about it. I think it's actually a good quote. I think. So what do you think about that then? What is the right way? Should we remove regulation? Should we change the approach? Do you have any thoughts about that?
You could imagine many ways of trying to do this. One would, of course, first of all, be to say that yes, we can have sort of. I think it's hard to do regulation on the technology level. I think you need to do that on the application level rather.
Hallelujah.
So if you're someone like us, you should be able to do whatever you want if it's for a good cause. But if someone is doing it to manipulate teenagers to go on strange diets, then maybe we should have some kind of regulation for it.
But that has been the core discussion on this podcast. And this hypothesis has not been able to... no one can fault it so far. Don't regulate the technology, regulate the application. Very, very simple. It goes back to the hammer example.
Yeah.
So don't regulate the hammer. Regulate what you do with the hammer.
Exactly.
It's very basic.
But it's very, I mean, we've been...
But okay, so let's steelman this conversation now. So is there a reason why we need to think differently with AI than with the hammer? Or is it, or because as soon as we do that, we get into all these sorts of troubles that we now highlight that, all the good guys, only the good guys care about regulation. But are there any reason why the technology needs to be regulated away from the application?
So I'm a pretty relaxed guy. I still don't see what the models are capable of as needing any other regulation than the hammer regulation. I think, or at least as we said, there
application is the key here.
I think so.
Should we go the AI Act route? Let's try to keep it short here. But have you been following the AI Act development and potential soon implementation?
To be quite honest, I have bigger problems in life than that.
Let's skip that topic then. But in general, do you think it will be a problem for Europe, or will it be a benefit for Europe that we will at some point soon have an AI Act?
Is it net positive or net negative?
I unfortunately think there's a risk of it becoming a net negative. And you can just see. Look at GDPR, which is sort of simpler in some ways. Already there we are seeing challenges in what kind of models we can train. We had a project with AI Sweden, Recorded Future, a couple of years ago when we built a model for doing Swedish named entity extraction. And the training data set, the main challenge in that project was not technical. It was actually convincing the other parties in the project that it's okay to use this model, even if it might inside the model somewhere contain personal identifiable information.
Yeah, it's such an interesting topic, and we know that Google Bard, when they released that, they stayed away from releasing it in Europe.
So I think that's a great indication that we could be in trouble if we regulate in the wrong way. It doesn't even need to be true. It's just that the perception of Google was that it might be unsafe for us to do this, so let's stay away.
Yeah. But in the end, it has. If you look at the butterfly effects of what we're talking about now, it could be the start of the teardown of the European Union. Because at some point you get to a point where countries or entities cannot or don't see how they can participate anymore. And if you think about where that leads, it's not a good place. In my opinion,
I'm also torn, but and I think the sad, what makes this tough is that, this is based on very good intentions, right?
Yes, of course.
And it's very hard. Honestly, I think it's extremely hard to see what's the right level of regulation to have here.
But I think the deeper question here is like there's been many articles on this, and it's like what we have learned from the past when we had real deep innovation like nuclear weapons. We realized this is something that profoundly changes the fabric of society. So we need to figure out a way to globally regulate this. I think this is the main flaw, that this is the pink elephant, that you cannot regulate AI in a local region. Impossible.
I actually just read this. I was amazed that Henry Kissinger and Eric Schmidt wrote this book on AI. I'm not sure if you read it, The AI Age. I can actually recommend it.
Yes, I know it. I haven't read it.
But the interesting point they make is that the reason nuclear regulation worked was that it's big, expensive, complicated technology which you can detect if someone has. Whereas, as you say, for AI, you can run it on your laptop. How on earth are you going to be able to regulate that when you can't detect it?
And someone else said the same, right? So with nuclear, there was a reason how we could come together on this, and those mechanisms that made that possible to have a global view on it, or go into a global negotiation on it, is vastly different now. There are many facets why this is different now. We need to do the same thing, in my opinion, but I don't know how. I really don't know how.
Perhaps we can just if we backtrack a bit here and think about cybersecurity in general, there's a lot of traditional cybersecurity products out there, and everything from traditional like computer network exploitation tools and scanning software, etc. But I heard sometime you spoke and you try to differentiate what you do, speaking about the intelligence part compared to the other products or type of products that's out there. How do you understand what I mean? Can you just elaborate a bit more?
I think one big distinction is if you look, I mean, so as I said, we're very external. We like to look at the external view of everything. And then, if you have your endpoint detection software or your network, local network, if there is such thing as a local network anymore, monitoring, you want to do both, because what you want to do is you want to correlate your internal observations with the stuff that we know from the outside. Best example is, if we have a list of current command and control IPs, we give it to you.
You for people that are not too into cybersecurity and describe what command and control is.
Okay, sorry. So, the way malware, let's take ransomware to be more concrete as an example is, so someone infects your machine and that spreads to other machines in the network. And then that's what they do in the end is they encrypt all your local files, but they also send a backup copy back to home base. So home base is the command and control node. That's what they use both to control what's happening.
On the internet somewhere.
Some machine on the internet somewhere. And those are fairly stable over time. They change, of course, but every day, so we typically have a list of something like 25,000 active command and control IP addresses every day. So if you monitor for that in your local networks, seeing one of those is a really good indication that you're in trouble. Yeah. And you have very short time to do something, but you can actually do something. So the correlation, so the part is that you get the external view, you take your internal observations, you correlate them, and you can find indications of trouble.
So basically it's a complement to the traditional products out there that adds the intelligence of what's happening throughout the world and the intelligence graph that you have. And by combining the two, you can find more vulnerabilities.
Can you simplify it by talking about reactive versus proactive approaches here?
Yeah. No, that's part of our usual pitch is, of course, that, I use, when I talk about this, usually I have this picture of a medieval city saying, with the wall around it and saying that this is how we've been doing IT security since the Middle Ages. And it's very true. I mean, and the security guys, what they do is they focus on building this wall as high and thick as possible, and then they run around on the inside looking for bad things which have happened. So as you say, reactive. If you're proactive, you can actually be on the outside of the wall. You can actually see that
spies out seeing where they're coming from.
You can see that there are guys, the horses are approaching. There's a cloud in the distance indicating that the horses are there. You can see someone selling the keys to your doors. You can see people selling things which have obviously been stolen. Then you're still reactive if you like, but still. But you can get the early, or you can see people on the outside asking for, saying, I want to attack this city. Does anyone have keys for sale? Which is exactly what you find in the criminal forums, by the way.
So someone could in the forum say, I want to attack Ericsson now or Spotify or whatnot, and that is something you could potentially detect in some way. Then.
Yeah. So bottom line, when we're talking about the old is wrong, the cybersecurity, the normal cybersecurity view versus threat intelligence is how we maximize the value and the opportunity by combining reactive and proactive measures, and we can take that into, if you want to exemplify, you can take it into health, right?
Yeah.
How do we prevent disease, or how do we prevent accidents versus what we do when the accident
I like to think of it really as how do we identify the weaknesses that we know the bad guys are going to find if they go out and look for it. When you clean up those, essentially what you do is you increase the cost of attacking you. So and if nothing else, what that's going to lead to is that there is someone else who is cheaper target, and they're going to go after that because, these guys are lions. They go after the slowest antelope on the savannah.
And perhaps also to just give a quick intro to the cybersecurity type of threats, are there different categories or types of attacks that you could try to list to describe for people? You mentioned ransomware, malware.
I was going to say, if you look very broadly, I think there are three kinds you can think about today to simplify things. One is denial of service attacks or distributed DDoS attacks, which is essentially making your system unavailable. That's one category. Can
you protect against that, or do you do that with?
it's not our primary thing, but actually with the network collection we're doing now, we're actually working on an edge-based model for indeed finding early signs of DDoS attacks. But that's new stuff, not out yet. The second one is, as you said, to keep track of the ransomware gangs, which we can help in different ways. We can identify stolen credentials. We can scan for vulnerabilities. That's the second most common. Stolen credentials is the most common attack vector. So people don't break in; they unlock the door because they stole or bought the credentials.
They have the key already.
They have the key, exactly. And the second one is the vulnerabilities, because people haven't patched their web servers, etc. And the third one is actually people, like the Coop case here in Sweden, where someone has purchased a nice remote management system. Unfortunately, the remote management system can also be used to install malware. So we can help monitor for those kind of things, if you like.
Interesting. And if you were to imagine that I had a company and I wanted to keep it secure, and let's say it's an old company that had most of the stuff on-prem, and now they're thinking, we want to make the company as secure as possible. And some people claim that going on cloud is a positive thing. Others are saying, keep it, with air-gapped systems, etc. That's better. Any ideas about, how should you, as an chief security officer at a company, reason about keeping the company as safe as possible?
I mean, it could be so many other factors in this, but I honestly, we are running all our stuff on AWS on the cloud, and I think the basic level of protection you get by what any of the cloud providers provides you in terms of security is actually a much better starting point than what your old company is probably going to be able to do themselves.
Right.
And this is, I think this is a fact now, but I remember a couple of years back that this was a simple argument we had in Vattenfall and Spot. In Vattenfall at the time, and for me it was super simple. You will not be able to patch your. And there was this huge argument, but people don't really understand how vulnerable the on-prem setup is.
Yeah.
And so, could you just give example? Is that simple, right?
Take and let them be anonymous. But one good example of one Swedish company which was hacked a couple of years ago, the way they were hacked was that some subsidiary of them somewhere in the world had a sort of a secure network and a less secure network, and it was very complicated to do things. So some guy somewhere on the other side of the world decided to take a patch cable and connect the secure and the insecure network.
I think I know the company, but I won't. Okay.
And then, touché, someone used it and got all the way in.
Yeah.
And if you're in a larger enterprise, that you don't have those small holes or leaks in security is virtually impossible.
Yeah, no, everyone is vulnerable. It's
and then to think that you're spending the same amount of money to keep it all clean compared to one of the big cloud providers is ridiculous.
Yeah.
Because the amount of effort they put into this, because they have thousands of customers and their whole reputation relies on it.
Then of course, as I said, it's not that simple, because since Anders' old industry has all this factory automation, operational technology, which you can't put in the cloud because it sits there and controls motors and stuff. So he's still going to have part of it which is physically on-prem.
Yeah. So this is one of the key challenges when we are moving into the, how should we put it, the analog or physical asset intensive world.
But if we let Staffan has limited time here, Henrik.
Thank you.
And if we just were to get your best advice for a company to try to keep their systems as safe as possible, I guess one advice would be try to move to the cloud if you can.
I usually say first one is to do sort of basic cyber hygiene. So make sure that you have good authentication. Multi-factor is decent, but you should have it with physical tokens or whatever like that. Yeah. Second one is to make sure that you patch your systems, and prioritize that. That's a different story about how you use the intelligence graph to prioritize, but you won't have time for that today. But I think most important is actually education and training, to do your very basic stuff, right? To train your employees in how to not do stupid things. Practice what do you do if you see an emerging attack, and so on.
Right. And you forgot, I think, most important. It sounds like I'm pitching your company for you, but I guess they should buy a Recorded Future product.
They should have some threat intelligence to understand what their threat picture is. Absolutely, but I'm such a modest guy. I don't want to advertising on this pod here.
Cool. What do you think in general about the cybersecurity? We spoke about TLRs before. You spoke about Henrik. I guess we could speak about some kind of readiness level for security as well. What do you think about that level and understanding in Sweden is going? Are people getting increasingly knowledgeable?
I mean, of course, people are more aware now than they were a couple of years ago. I mean, the good news, I think, is that management and boards and so on actually are realizing how much it can cost. It's been good that we've had a few attacks.
We have been burned a couple of times now, so it becomes visible.
But still, you've probably seen this report we wrote at the Royal Swedish Academy of Engineering Sciences, where we highlighted a bunch of problems. Biggest problem probably being, and now it becomes very personal for Anders here, is the fact that the government agencies who should help both the government and the companies protect themselves really haven't had their act together yet. It's not your fault. You're just close to it.
Yes, no comment. But we can all improve, I think, in our understanding of how to protect for cybersecurity, for sure. Cool. And since you have to leave in about 10 minutes, I'd like to go a bit more...
Or 5.
For 5 minutes, okay.
10.
A bit more philosophical as well.
Mm-hmm.
And, we mentioned... Let me take this one. So, if we speak about AI in general, of course it can be a threat not only to cybersecurity but society in general. And Jeffrey Hinton, famously left Google recently.
Mm-hmm.
And he said that it's, he's basically the founder of so many of the techniques that are being used in GPT today. But he said, I think an interesting thing, basically saying, before he wanted to use AI to understand the human brain, and he thought, there are so many differences between the human brain and AI today, so it's so far off. But then he said basically, well, the differences isn't necessarily mean that the AI is behind. It's because there is differences that AI is surpassing the human brain, basically saying that GPT, if we take that specifically, let's see if I can recall the numbers now, but GPT can be seen, especially, like you compress all the world knowledge into a big model, and that model has, I think, let's say it's 1 trillion parameters or 100 million billion parameters, and the human brain has around 100 trillion synapses in the brain. It is significantly less, the model, but it can store at least knowledge more than 1,000 or 10,000 people has. So in some way, it's more efficient. It's significantly more efficient, potentially, than the human brain is in storing knowledge. So he sees that yes, there is differences, but potentially AI is more efficient than the human brain today. Would you agree with this?
I don't know. I think the thing is that, the models, the language models only store language, right? And if you look at the human brain, we have all the visual stuff, we have all the... if you like, the sort of laws of physics, everything we learn from having our bodies interact with the real world. So there's more than just language to what we have in our brains.
That's one part, but given that it seems to have a technology that is different from the human brain, but potentially more powerful, then if we add images and all the interactions of the
which
world...
is of course happening now, so it's...
Yes.
If you look at it sort of at a higher level, I'm still... I still have my basic feeling here is that we're creating amazing new tools for ourselves, but I still don't see it as a new species. I see it as a sort of extension of humans. We're getting very clever little agents sitting on our shoulder, helping us in understanding things and so on, and communicating with the other agents in the world and so on.
But let me take another spin on this. Because, what Anders is onto here, I've lately been thinking or reflecting on, the general debate and discussion, and it seems like, there's been this, do we try to measure AI, the computer intelligence, if I don't know what is the right word, against some sort of human yardstock of anthropomorphizing. I can't even say the word.
Anthropomorphizing.
So, and maybe one of the problems here is that we are trying to put another completely type of intelligence or another type of maybe it's the wrong word to use, intelligence even, but a capability into like a round peg in a square hole and trying to understand it from the
in terms of us.
In terms of us, right?
Yep.
And that fucks it up, right? We don't realize, the value, and potentially we don't see the risks properly, because we are trying to take this square peg now into a round hole, and we get into a debate instead of really trying to understand. We are reflecting on AI from the human perspective instead of empathizing with AI from what AI is from its own perspective. Do you see what I mean? Like,
and I think I never thought I would quote Kissinger twice, but they actually in that book have another thing they talk about at the very end, which is exactly this: that let's say we use AIs in natural sciences. I mean, when we do natural science, it's based on our perception of the world, given the sensors we have, etc., etc. But if you have someone who comes from a completely different angle and tries to understand the world, they might see completely different things.
Touche, right? And then maybe that's part of the problem of the whole debate and how we are trying to regulate and everything, that we are there's something. It's called empathic listening or reflective listening. If you listen to a guru like Steve Covey, like if you really want to be effective in communicate with someone, you need to empathetically understand where they are coming from. And the whole debate now is completely reflective. We are trying to understand AI from our own psyche and our own views. And I think that may potentially means that we don't understand the value and we don't understand the risks.
Yeah, no, absolutely. I think the only thing we do know right now is that we live in extremely exciting times.
Well said.
Are
you scared or optimistic about the future in 5 years ahead, for example?
So I'm more scared of humanity than I am of AI, if you like.
If I could quote what we have said a number of times, I'm less afraid, when we have general intelligence. I'm much more afraid about the narrow intelligence and how that can be abused in current wars that we are seeing. Would you agree with that?
Yeah. No, I agree.
But we can screw this up way before we have general intelligence.
We don't need that to screw up the world, right? Yeah. I mean, we've already proven that.
Humans can screw up the world with stupid intelligence in so many ways.
Yeah. On that positive note...
But it can be a beautiful thing.
Yeah. But are
it's like Cinderella, right?
Let's do it like this. Are we take optimists or take pessimists?
I'm optimist.
Yes, yeah. I'm too.
Yeah, me as well. Staffan,
on this positive note.
Exactly.
You have to leave very shortly. What's next in your life? What's happening coming hours, months, weeks?
Sailing, hopefully.
Ooh.
That sounds awesome.
Yeah.
Where are you going?
Sailing on the west coast in Sweden.
So you are a bit of a boat...
A bit, not great, but enthusiastic.
And where do you sail on the west coast?
Up and down. That's what everyone does on the west coast. Actually, I'm going sailing tomorrow afternoon. We're going to do. There's a yearly 24-hour sailing race, which some friends and I do every year. So that's starting at 6 p.m. tomorrow.
Oh, you're on the clock already almost.
Exactly.
12 hours.
Right now this is the interesting part where you need to figure out where you're going depending on the weather forecast and the wind, so on.
Anyone that you would recommend to this podcast? Someone that you think would be interesting to listen to and for us to interview?
I already quoted him twice. It's Henrik Kissinger.
Thanks.
We have to have an AI bot, a language model that can impersonate him. Awesome. Staffan, it's been a true pleasure. It was a bit strange for us to have such a short podcast.
From 3 hours to 1.5.
Maybe focus, guys. It was great. Great to be here.
Great to have you here. Thank you again and have an awesome evening.
You too.
Thank you.
Thanks.
Thank you.